Good morning. Thank you, Hailu, for that introduction, and thank you, Andrew, for the perfect introduction, really, to our program at the Office of Radiological Security and what I'm going to talk about today. So I'm going to talk about what we do at PNNL in support of alternative technologies, both domestically and internationally. Note that there are others throughout the country and internationally especially working on this issue. So what I'll talk about here today is the focus on our perspective. So here's a quick summary of the Office of Radiological Security. Again, we're within the National Nuclear Security Administration. And the point that I want you to take away here is that we view alternative technology as just one piece in a bigger picture in support of radiological security. And so you can see the three pieces there, and you can of course see our mission statement at the top. We are motivated by security, keeping these sources from being used in acts of terrorism, as Andrew described. So we do that through these three approaches described here. We have a protect strategy whereby we install security upgrades and work with sites and law enforcement to make sure the response is the best it can be in the case of some kind of incident at one of these facilities housing this material. We also have a remove strategy, so this is where if there is material out there that sites no longer wish to have, we have a program by which we can come out and help sites get rid of that material, move it to a secured location elsewhere. Depending on the situation, if we're talking about high activity rad sources in the United States, this is generally the only game in town. There's not a commercial disposition pathway for these sources above a certain activity level that includes the vast majority of the type of radiators we're talking about here today. There is generally no commercial disposition path, so our remove program is the way it's done typically. So, very powerful program. The reduce effort on the right there, this is a newer approach for our office, but is of course the focus of what we're talking about today, and this is our support of alternative technologies. But again, we're looking at that from a risk reduction perspective, the permanent risk reduction that Andrew talked about. At the bottom, there's some points that, yes, terrorism, Andrew covered that. Not all radioactive materials pose a concern. Andrew mentioned that as well, so I'll go ahead and move on. This slide provides an overview of the life cycle of rad sources, and I use this to emphasize a couple of points. One, it shows where all the Office of Radiological Security is involved in the security of these sources, as well as it shows how switching to an alternative technology avoids the security concern at all of these steps. So I know the small text may be hard to read, but at the top left we start with a reactor that makes these radioisotopes of concerns. So there are site security enhancements that can be there. A source device producer, so maybe this is where the source is put into a blood irradiator or so forth. So they're handling sources. Security enhancements are needed there, and we work with these sites. The third one on the right there, that's the user. So there you're talking about hospitals and universities, more security there. Storage, and then the final one is final disposition. So more places, so sources move through all of these different places, and I highlight in orange the box on the right and the orange arrows that of course in between each of these is transportation. So this is another vulnerable place where sources are moving in trucks and concern for theft at those points is high as well. So that's a lot of places where a source moves. It's a lot of locations, it's a lot of time in transit. So from a security perspective, non-isotopic alternative technologies, skip all of that. So we find the permanent risk reduction from alt tech very promising and very useful from a security perspective. I'll add that this is not mentioning some of the benefits that users see. So this includes not having to deal with the hassle of some of the regulations, of the background checks, not having the hassle of having to use biometric access to get into your room every time you want to irradiate some blood or so forth. So there are a lot of benefits from the user perspective. These presented here are more from the broader RAD security perspective. Okay, this slide provides an overview of the Office of Radiological Security's approach to alternative technologies. So some of this is already covered, some isotopes on the left. I'll skip over that since Andrew talked about that. I'll reiterate that commercially available non-isotopic technologies are available for the majority of applications that use these sources. And I list some of them here. Including blood, radiotherapy. So in this venue, we're focused on these self-shielded irradiators for blood and research, but I'll point out here that at the Office of Radiological Security, we look at these sources broadly in all applications. So that includes things like radiotherapy, industrial sterilization, radiography. Well logging is on here with an asterisk. Well logging is a bit more complicated. It's a very challenging environment in that arena. Alternatives exist for the neutron source that they use, but they also use a photon source, and it's not generally viewed that there's a viable alternative for the photon source in well logging. So that's an area that's still under R&D, and we're working on. But in the other areas listed, alternatives do exist. The strategic approach here on the right shows the 4 strategies that we use at ORS to support alternative technologies. And this set of strategies will also form the outline of my talk going forward. So on the left, you see policy engagement. Here we work with the interagency, and we work to set policies that will encourage the adoption of alternative technologies where feasible. The second one is device replacements, and that's where our irradiator replacement program that Andrew alluded to fits in. And at the bottom, you see in the United States, the cesium radiator replacement project. But also at the bottom right, you see internationally, we're looking into pilots to do similar things, to replace cesium irradiators or cobalt-60 teletherapy units for cancer treatment. And I'll talk a little bit more about that later on. The third strategy, outreach and education, which you're looking at that here today, supporting efforts like this. We find that that is one of the most important areas to work to promote alternative technologies. A lot can be gained by having dialogues among stakeholders, among experts in venues such as this. The final one is research, as I mentioned with well logging as an example. Some research needs to be done for the alternatives there, but we coordinate with an R&D shop at NNSA. It's not the Office of Rad Security, it's a separate office within NNSA, but we coordinate with them on R&D in support of source replacement. All right, so start with policy engagement going forward. Here provides an overview of the domestic political foundation in support of alternative technologies. A key takeaway here is that support of alt tech is not just a National Nuclear Security Administration effort. This is an effort for multiple agencies in the government, and I think the last point mentions non-governmental organizations and academic reports also supporting, including the Nuclear Threat Initiative. So a couple on here to highlight. The top one is created this report that's in the bottom center, rad source use and replacement. That was the National Academy of Sciences. That is sort of the go-to guidebook for everything alternative technology. It's a little bit dated. It was put out in 2008. And on the next slide, I'll follow up on that. The second item here, the Radiation Source Protection and Security Task Force. So this is an interagency task force led by the Nuclear Regulatory Commission, produces reports every 4 years. You can see some of the recommendations from these. So the NAS recommended that the US government adopt policies that provide incentives to facilitate the introduction of replacements. The task force report recommends the US government incentivize alternatives and lead by example in the adoption of alternative technology alternatives. A little redundant. The bottom one on the left is a best practices guide from this working group on non-isotopic alternatives. This report came out in December, so this is the most recent item on the list. So this was an interagency report aimed at the federal government to see what federal agencies can do in support. I'll skip through the others. Andrew mentioned the replacing 34 irradiators at the Security Summit. So let's move on to here. Here are a few of the policy working groups that we're involved in that are active at present. The bottom one I mentioned a moment ago, that's this task force on rad security. Let's see. The one in the middle. Co-chair, but yeah. Okay, yes. Gotta get which one's which. All right, so covers a group that ORS is working with. We're looking to update that National Academy of Sciences 2008 report on alternative technologies to provide the current status of technology for these applications. So the 2008 is a little bit old. A few things have changed in with regard to what the technologies are available and what their capabilities are. Okay, so moving on. I thought I had another slide in there. So moving on from policy, I'm actually moving into our replacement efforts. So Andrew covered this a little bit. Here's just a quick overview of blood and research irradiators and what the alternatives look like. This audience probably knows, but blood is irradiated to prevent transfusion-associated graft versus host disease, which is not terribly common, but when it occurs, it's typically fatal, so it's a big deal. In the United States, I believe it's something like 40% of our blood is irradiated for this purpose, but that varies as you go to other places. In Japan, it's 100%. Other countries do things differently. Some countries, if you're looking internationally, don't irradiate blood, but they are looking to do so as their healthcare system is becoming more mature. Research irradiators are used to study radiation effects on biological samples, and that's vague because there's a lot of different research out there being done with these irradiators. Maybe it's cell cultures, maybe it's small animals. Some use these outside of the biology field and study materials effects with these research irradiators. So that's a wide space that's a bit more complicated than blood irradiation. Currently, 2 FDA-approved X-ray blood irradiators, or X-ray blood manufacturers, each has a couple of models, exist in the United States. And there are currently at least 7 X-ray manufacturers. So quite a few options out there for alternative technologies. I'll also highlight on the bottom here UV pathogen inactivation technology. So this is relevant for blood. This is an interesting example of an alternative technology because it does not rely on ionizing radiation. We typically think of alternative technologies as some kind of X-ray source that replaces the radiation from a rad source. Not the case with UV pathogen inactivation. The idea here is this technology uses a chemical agent that when activated under UV light, which is non-ionizing, activates to disrupt the DNA in pathogens. It was actually originally intended for pathogens like HIV and Ebola and so forth to remove those from blood products. But it has more recently been indicated to be useful and be effective in combating transfusion-associated graft versus host disease as well. The status of UV pathogen activation, though, it's not good to go here in the United States yet. It is CE marked and it is widely used in Europe and the Middle East, but here in the United States it is not FDA approved, at least not for all blood products. It's approved for platelets and plasma, and if you're familiar with blood processing, you can process whole blood or platelets, plasma. You can break blood into components to get those. So for whole blood or red cells, UV pathogen inactivation has not been approved by the FDA for use here in the United States. Many of us are keeping our eye on that to see if that approval will come down the line, and we'll see how it goes when that happens. A lot of people are highly anticipating that. But the technology is not new, and it's been used internationally for a number of years. The considerations for replacement. So deciding what technology to use or whether to replace a cesium radiator with an alternative, it's a big decision and it's a complex one. And here are just some of the considerations that we've seen as we've worked with sites interested in making this technology change. And this is a good place to point out that everything that we do in the Office of Radiological Security is voluntary. We are not going out and telling any site that they need to change technology. There's no requirement like that we can make. So we go out to sites and we present them up front. Here are some of the considerations that other sites have expressed. I want to make sure that you think about these as you look to change technology, because we also don't want any site to change to a technology that does not suit the needs. We understand that these technologies are used for crucial medical applications, and their ability to function in that role is crucial. So some of these are kind of obvious. Cost, of course, you're concerned about cost. But there can be pieces of that: infrastructure requirements, operating costs. If you're talking about a source technology, the cost of disposition of the rad material, reliability. And here I say actual or perceived issues with reliability. It's generally viewed that some of the original blood irradiators weren't as reliable if you go back a number of years, but some of the modern ones have shown more reliability, and we'll have some folks talk about that later today. Information gaps, that hinders everything. Make sure everyone's on the same page. Throughput is a key issue, of course, for blood irradiation, depending on how many units your facility needs to process. And for that, throughput doesn't necessarily favor cesium or X-ray. It depends on what model you're looking at. So the throughput is comparable and in some cases better for X-ray. An extra benefit that I'll point out for X-ray for throughput is that the X-ray machines don't decay, so their throughput stays relatively constant over their lifetime. Cesium decays, so you have to factor that in, that your throughput will change over the years. Radiation dose profile, that's a key one for research, medical research. As we understand, and there'll be more talk about this today, some research would benefit from, some research requires the spectrum from a cesium irradiator, and some research does not. So that's a lot of what we'll talk about today, is getting into the detail there. Yeah, okay. All right, so let's talk real quick about what we offer to help sites change technology. This is the cesium radiator replacement project. Andrew summarized it, so I'll make it really quick. On the left side, you see what qualified sites receive. Sites receive the removal of the old irradiator, the cesium irradiator. We cover that entirely. They also receive a financial incentive. It's a cost share. The idea is 50% of the device, but that can vary depending on site-specific circumstances. It's worth knowing that that incentive comes after the fact, after the X-ray is installed and after the cesium device has been removed, then that incentive comes into play. On the right, qualified sites are responsible for a number of things. So there's some paperwork. There's a disposition statement that we require of sites saying that they're participating in this effort in good faith. I think the most important part here, though, is the second and third bullet, that the sites are required to identify the irradiator, the X-ray irradiator that they want, and purchase that device. And I think it's important that that is on the site's responsibility. The site knows what they need a lot better than we do. You know your throughput requirements, you know your research requirements, so we look to the site to make that decision. We can provide some resources to support that. So the accomplishments at the bottom. So this is a relatively new program, but it's ramping up quickly. So you see in the first point that we have replaced 8 irradiators so far. But then if you compare that with the second, additional sites totaling around 70 blood and research irradiators have volunteered for the program. And that says for replacement in 2017 and 2018. That should include 2019 too. We're not doing 70 in the next year and a half. But we've had a lot of interest. It has grown very quickly. So I'll second what Andrew said, that with the interest that we're seeing, the sooner you talk to us, if you're interested, the sooner we can see where you might fit into the prioritization scheme. New York City is mentioned here, that effort, but that's been mentioned by others, so we'll go ahead and move on there. So let's talk briefly about international. I think I'm running a little low on time. The trend internationally, or there is a trend internationally in support of alternative technologies. Globally, many countries have transitioned. Andrew talked about this, but I'll point out that there's also a trend in cobalt-60 teletherapy units being changed to linear accelerators for cancer treatment. And that trend, that has been a long-standing trend. In a lot of the Western countries, largely that has already taken place. Largely folks are using linear accelerators rather than cobalt-60, but that trend is continuing elsewhere in the world. Also, electron beam technology or X-ray for industrial sterilization. That's another one that we're seeing a trend towards switching to those. And then, of course, UV pathogen inactivation is viable internationally. It's worth knowing the international context has a few extra challenges, depending on where in the world you're talking about. You might have less predictable power, less predictable water supply. There might not be as many technical experts in that region. And along with that is that if the devices are in remote locations, it may be challenging for the device vendors to make it out to those locations and service those technologies. So the context internationally is a bit more complicated. So here's a summary of what we're doing internationally. The international program is a bit newer than our domestic program, so we're still working out a lot of how we want to approach this. So we are exploring device replacements, kind of like we're doing with CHIRP domestically. We're looking for places where we can replace, or we can support the replacement of teletherapy units, cobalt-60 teletherapy units with LINACs, as well as blood and research irradiators. We work with removals. I mentioned in the beginning that remove is a big part of what we do at Office of Rad Security. We do removals internationally as well. So we look for where we can partner, and perhaps a hospital internationally maybe they have a LINAC, but they don't have a good pathway to get rid of the cobalt. So maybe we can step in that situation and help them get rid of the cobalt so that they can install and use their LINAC. So we look for opportunities like that to collaborate. Outreach and education is a key one. I think the most important internationally and equally important domestically. We find that the international audience has the same questions for alternative technologies that those in this room have. Reliability, throughput, downtime, what are the infrastructure requirements, all the same questions and concerns. And the most important approach for making this change, I believe, is dialogue, is having venues like this, getting the stakeholders together to talk about it, getting the people that have experience with the technology and those that have questions about the technology in the same room, or perhaps in the same WebEx or same recording, or however it is we do it in the modern age, but getting these people together so they can talk about the technology. And so that's a primary effort for us internationally, and one example of that is the World Institute for Nuclear Security. We work with them, and they have a special report on alternative technology that I recommend you check out. Low on time, let's skip that. A couple of specific efforts for our international collaboration. We have a targeted initiative on radiological well logging source risk mitigation. So I guess I won't spend much time on that because we're not talking about well logging here today, but that is a primary effort for us in Kazakhstan and Ukraine. The IAEA is, of course, a major player internationally looking at rad security, and we collaborate with the IAEA extensively. Technical cooperation projects on rad therapy, medical physicist training. We partner and we support this IAEA ad hoc meeting of stakeholder states